everyone, welcome back to my channel. Today I am doing a walkthrough of the CCEA 2019 Maths Pure Paper. I have just turned the camera on and done it. I've finished doing it now and I can say you'll be fine with the paper, but this is a walkthrough. If you want to do it along with me, go ahead. If you want to maybe print out the same paper and do it along with me, or just have a notebook and write down as we go along, that's great too. Enjoy. Enjoy. Okay, let's begin. This is AS1 from 2019, if the camera would focus. So, the paper starts off arguably very nicely, arguably not very nicely, with solve the simultaneous equations. So, basically with simultaneous equations, what you want to do is zoom in slightly. We're going to want to eliminate the easiest letter. So if you look at them, basically what shows the least variation in number, we have 1, 2, 3, 2, 1, 1, 3, 4, 1. As you can see, y shows the least variation, so we're going to get rid of y's first, because it'll be easiest. So to start off, let's go for equation 2 and 3. I'll label them 1, 2, 3. And we're going to start off with equations 2 and 3, and we're going to eliminate y. So step 1, just write it out. 2x minus y plus 4z is equal to 17. And then write out the equation 3. 3x plus y minus z is equal to 2. Different signs. We add them. And we're going to get rid of the y's. 2 plus 3 is equal to 5. Minus 1 plus 1 is equal to 0. 4 minus 1 is 3. 17 plus 2 is 19. And now let's take equation 1 and multiply it by equation 3, because you can see 2 is a lot smaller than 17. So remember that has to be multiplied by 2, so we have 2y and 2y. X plus 2y plus 3z equals 9. And we're multiplying this by 2. 6x plus 2y minus 2z equals 4. Same sign on the y, we subtract. X minus 6x is minus 5x. 3 minus minus 2 is plus 5z. And 9 minus 4 is equal to 5. Interesting equation there. Okay, now let's look at these two. What is easiest to eliminate? X or z? Well, we have 5 and 5 minus 5. And 3 and 5, I think x. Always write them out again. Equals 19. And then minus 5x plus 5z is equal to 5. Different signs, so we're going to add, and we get 5, 6, 7, 8z is equal to 19 plus 5, which is 24. Z is equal to 3. And as you can see, we haven't even used the calculator yet, which is quite useful. You know, you can get it all, this pretty much all done in your head. Okay, now let's sub z equals 3 into the easier equation. This one's probably the easier equation. 5x plus 3 is equal to 19. 5x plus 9 equals 19. 5x, take away 9 from both sides, we get 10. X is equal to 10 divided by 5, 2. And now let's look for y. The easiest equation is probably number 3. So 3x, x is 2, we know, plus y minus z, which is 3, is equal to 2. So that's 6 plus y minus 3 equals 2. Now that is 3. And we're going to be taking away 3 from both sides, which gives us y is minus 1. Always nice just to put them all together at the end again. X equals 2, y equals minus 1, z equals 3. Solution. There we go. Now, that does look like I'm saying 3 is 3. You could just say z equals 3. Okay, let's move on to part... Oh, lol, that is hilarious. Part B. Okay, vectors. Find the magnitude of the vector A, B. Now, the one thing you have to remember about vectors is that AB equals basically this, AB, but it really equals this plus this. Should have had an arrow there. You always may have to make sure you're going from the vectors you know, and we know what O to A is and we know what O to B is. We do not know what A to B is, so we have to use what we have to work this out. So A to O is just that backwards. AO equals minus 4i. That's not an I, is it? That's a j. Minus 4i plus j. And then we know that O to B is equal to 6i plus 2j. Now we want to work out the vector AB, so we're going to add them together to get that. So, pretty easy. Add the i's, add the j's. AB is equal to 6 minus 4, 2. 2 plus 1, 3. Now we're looking for the magnitude. We have the vector quantity here, not the magnitude. So to work out the magnitude of AB, the lines just mean magnitude. This is equal to taking Pythagoras to it. 2 squared plus 3 squared, which is equal to root 13. Now if you didn't know that, you could work that out in the calculator. That's just one that I have learnt. Now this is part 1. Part 2, I'm guessing, is going to be now find the direction. Yep, find the angle. AB makes the positive x-axis. So, to work this out, it's actually pretty simple. If we were to draw out AB, let's look at it again. You could say that this would be equal to, just a very quick sketch, ij. It would be equal to 2 in the I direction and 3 in the j direction. 2, 3, there. There's our triangle. So let's draw that out here. Maybe slightly neater. Here we have I, here we have j. Definitely not drawn to scale. 3, and that is that vector there. So we are looking for angle with positive x-axis, that's in here. Let's draw out the triangle, bigger again. Right angle triangle, that is what we call theta. This direction 2, this direction 3. That is opposite, that is adjacent tan. Basically tan to the minus 1 of O over A, which is 3 over 2, equals theta. You could work that out, tan of theta is that, then take the inverse, but I just like to go straight to it. And then we will be using our calculator here, and I'm going to make sure that I am in degrees because that is the mode we need to be in for this. Let's move this up. Okay. Can you see the screen? Good. Tan to the minus 1 of 2 over 3. Nope, it's 3 over 2, isn't it? Is equal to 56.3099. Now we give our answers to 3 significant figures. So 56.3. Okay, question 2. We have a sketch of a graph. Point A has coordinates 0, 1. Let's zoom out a little bit. We're going to write down the coordinates of A after applying the following transformations. F of x plus 1. So this is the entire thing's fx, and we're adding 1 to it. Basically means we're just going up by 1. So if A is equal to 0, 1, and we're adding 1 to the y coordinate, it is going to go to 0, 2. Okay, y of x minus 3. If it's inside the bracket, we're applying it to the x coordinate. Because we're minusing 3, x is going to be equal to 3. So basically we're shifting it 3 to the right, because remember you have to basically, x is the sign flipped. So if the x coordinate is 0, and we are adding 3, not taking away 3, remember, it's going to go 1, 2, 3. Our coordinate is going to be 3, 1. Now, y equals f of minus x. Okay, what are we going to be doing here? Now, if you minus inside, you're minusing the x coordinate, and our x coordinate was 0. So, nice and simple. 0, 1. Just as it originally was, because you're minusing the x coordinate, which equaled 0. If the point was 1, 1, it would go to minus 1, 1. Okay. Fx is an asymptote given by the equation y equals 0. Write down the equation of the asymptote of the curve under the transformation y plus 2 equals f of x. Now, we can rewrite this as y equals f of x minus 2. That's just literally bring that over to the other side. And if our asymptote is at y and the curve is moving down by 2, y is 0, all we have to do is move the asymptote down by 2. So the equation of the asymptote, we can say that that is that. Therefore, answer y equals minus 2, because we just moved it down by 2. Okay, great. Time for logs. Let's zoom in again. Question 3. Okay. Log 2 to the a, log base 2 of a is equal to 3. Now basically the rule of log is that to the power of that equals that. So let's rewrite this. 2 to the power 3 equals a, and we know that 2 to the power 3 equals 8. Therefore, a equals 8. Hence, solve the equation. Hence, great, okay. Log x of 2, or log base 2 of x minus log 2 x minus 1 is equal to 3. Okay, so if you have log of something minus log of something else, it's the same, and they have the same base, as you can see. This is the same as log of the same base of one divided by the other. So log base 2 of x divided by x minus 1. And this is equal to 3. Now, we know that 2 to the power of 3 is 8, as we saw. The value of a in the previous question was 8. So what we can say is, and it would be the case normally of 2 to the power of 3, x over x minus 1 equals 8. And then multiply both sides by x minus 1. X equals 8x minus 8. 7x equals 8. X equals 8 over 7. And that is that question done. Okay. Find the exact solution of the equation. Now, if you have a, you should be thinking, right, this is going to be a bit different. We can't just use normal logs, we've got to use ln logs, or ln, the natural log, because you have, your x in the power. Well, step 1, let's rearrange this so we've got something on both sides. I just stabbed myself in the eye with part of the stand. Great, okay. 3e to the 2x equals minus 4, bring it over. You have 4. Let's take the natural log. In fact, no, let's not. Let's get e by itself. E to the 2x equals 4/3. Okay, and now we will take the natural log of both sides. Ln e to the 2x equals ln of 4/3. Simple enough. And now remember one of the rules of logs. If you have your power, you can bring that down in front. 2x ln e equals ln 4/3. Now, a great thing about ln e is that ln e equals 1. You can check that on your calculator if you do not believe me. Ln of e to the power 1 is equal to 1. That's because it's base 8 log base e of e. I'll write that up here. Ln e equals 1 because log e equals 1. E to the power of 1 is 1. Or e to the power of 1 is e, sorry. Okay. So now 2x equals ln 4 over 3. And let's just divide both sides by 2. So x is equal to half ln 4/3, which all you have to do is leave it at that because we had to find the exact solution. There is our exact solution. Next question. Find the range of values for k for which the equation has no real roots. If you see has no real roots, you should immediately be thinking discriminant. 16. Okay, discriminant. Basically, what does the discriminant say? Well, b squared minus 4ac, that's what's inside the square root. To have no real roots, we want this to be less than 0. So, what is our b? Well, we'll write under this a, b, c. B squared is going to be k squared minus 4 multiplied by a, which is just 1. And c is 16, is less than 0. Great. Okay. K squared minus 64, that's what 4 times 16 is. Great. Is less than 0. Now this is nice, completing the square, or dots, difference of two squares, sorry. Because you have 1 squared, minus 64. So if we were to factorize this, it would be k plus 4 squared is 8. K minus 8 is greater than 0, quadratic inequality. Then you have our, your two solutions. Would be minus 8 and plus 8. We'll draw the graph. I'll just draw it like this. Here we have 8. Here we have minus 8. It is less than 0. Say y is less than 0. So we want this part of the graph. Y is less than 0 in here, because inside the curve, all the curve is under 0 in that part. So our solution is minus 8. If I was able to write it visibly, minus 8 is less than k, because k is in there, is less than positive 8. And that is your answer. That is the range of values for k. Okay, let us flip the page. Find the centre and area of the circle given by the equation. Now, this is completing the square to find the area of a circle. Great. So let's take the x's by themselves first. Now, remember, to complete the square, you divide this one by 2, x minus 2 all squared. Take out that part squared. Minus 4. Now we'll do the y's. Plus y plus 3 squared, take out the squared, 9 minus 3 is equal to 0. Now if you add up all these, minus 4, minus 9, minus 13, that's minus 16. So x minus 2 squared plus y plus 3 squared is equal to 16. And now remember that this is r squared, so the radius is 4. And the centre of our circle is 2 minus 3, remember, you have to make sure you change the sign because we're looking for what x is if that was 0. So this is the centre. And radius. It's not asking you for radius, but it's always good to write it down. 4. And our area is equal to pi r squared. Basically you need the radius for this anyway, which is 16 pi. And remember, if you're looking for an area, unit squared on the end. You could work out what 16 pi is, which is greater than 16 times 3. But it is not required, because you've just given the exact area. Okay, nice question here. I like this. We're going to be integrating. Now this looks like a horrific integration problem, but it's really not. So let's simplify this. We are integrating between k and 1 to this x. Remember, a square root is to the power of a half dx. And we know that this is equal to 28 over 3, and we're looking for what k is. So let's integrate. I didn't need to draw that again. Well done me. I meant to draw a square bracket. Okay. To integrate, add 1 to the power and divide by the new power. 2x, if you add 1 to this, it becomes 3 over 2. Divided by 3 over 2. Went outside the brackets a bit, but that's okay. Between k and 1 is equal to 28 over 3. Now let's simplify that. What is 2 divided by 3 over 2? I probably could do this in my head, but you know what? We're not going to do that. 4/3. Can we bring that up, multiply it? So 4x to the power of 3 over 2 divided by 3. And remember, we're still having to sub in k and 1 is equal to 28 over 3. Now we need to work out what k is. Let's move this all up a little bit. Okay, let's sub in k first. 4k to the 2/3. No, 3 over 2. That is a 3 over 2. Let's rewrite that so it's clear. Divided by 3 minus, we sub in 1. 4 times 1 over 3 is equal to 28 over 3. Now if we add 4/3 to both sides, we're going to do this in the calculator because it's quicker. 4k to the 3 over 2 divided by 3 is equal to 32 over 3. I'm just going off the page again. Well done me. Multiply both sides by 3. You know that 4k to 3 over 2 equals 32. K to the power of 3 over 2 is equal to 32 divided by 4. 8. K is equal to 4. Because we cube root and square. And that is that question done. Okay, let's move on. Let's zoom out a little bit. We're zoomed in very far. Okay. Let's put that up there. I do not have enough room on my desk. Great. Oh, okay, this is interesting. We zoomed in far too much there. Solve the equation. That's good. 2 cos squared theta equals 1 minus sine theta. So, for these questions, you only want one trig function in them to be able to solve them. Sips water. So, we know that, let me write this in red, sine squared theta plus cos squared theta equals 1. So, if we have cos squared theta, bring the sine over, 1 minus sine squared theta. So, 2 minus sine squared theta equals 1 minus sine squared theta. Now we want this to bring it all over to one side, and we'll expand through this too. 2 minus 2 sine squared theta equals 1 minus sine theta, and because this is negative, we'll bring it over. Equals 0. 1 minus sine theta plus 2 sine squared theta minus 2 is equal to 0. 1 minus 2 is minus 1. Let's all move over a little bit. 2 sine squared theta minus sine theta minus 1 equals 0. Now, the next step is to factorize this, which I like to do on the calculator because it's so quick and so simple. And when we factorize this, pretend sine theta is just x, we get sine theta minus 1 is equal to 0, and sine theta, 2 sine theta, sorry, plus 1 is equal to 0. So that is, the next step, which means that sine theta equals 1, sine theta equals minus a half. And then we're using degrees for this question because it's up there in degrees. So if I say, let's bring the calculator into the scene. You can barely see that. Sine to the minus 1 of 1 is equal to 90 degrees. Great. And then if I also say sine to the minus 1 of a half, remember this is 30. And I'm going to put negative beside this because sine is negative. Now, let's get our favourite cast diagram. That's why I remember it, cast. You could remember all silly tomcats, all sausages turn cold, I don't know, whatever you want to use. And I'm going to use red just to highlight this. So, whenever sine is 1, this is at 90 degrees. Oh yeah, I should write in the angles. 180. Okay. That is here, this line here, and it's for whenever sine is positive in those two. Now we're looking for where sine is negative, so we have, in the cos section, we have 30 degrees, and in the tan section we have 30 degrees. They're both 30. Sometimes it's easier just to not write it in and remember. So we have theta equals 90. There. Now remember, it has to be greater than 0. So we're going to say 180 plus 30, which is 210. And also 270, or should I say 360 minus 30, which is equal to 330 degrees. And that is that question done. You can check that if you have a graphing calculator, or you can check it if you substitute any of those values into this original equation. Okay. Oh, this question's, I'm already not, I know what it's going to be. It's going to be an optimization problem, but I'm not a fan of them where you've got a lot of different things. Okay, express h in terms of r. Now we're looking for a cylinder. Surface area is equal to 300 pi. Okay, the surface area is an open tin. So we have this part, and then we have that bottom part. I'm guessing those are the only bits we have. So the bottom part is a pi, or sorry, it's a circle, which is literally just pi r squared. And then we have this part, which remember is a rectangle, with the length, which is the circumference, which is pi d, or 2 pi r multiplied by h. Add them together and we know that this is equal to 300 pi. Now sometimes it's nice to factorize this because we do want it in terms of h anyway. So I'm going to go 2 pi r h is equal to 300 pi minus pi r squared. Look, we have a pi everywhere. Let's get rid of pi's. Cancel them all out. H is equal to 300 minus r squared divided by 2r. And that is h left all by itself. Now we're going to have to remember this, I'm guessing, whenever we turn over. Hence, show that the volume of the tin can be expressed as this. Now volume equals, for a cylinder, it is pi r squared times h. So volume equals pi r squared, and we're going to substitute in the value for h that we found, which basically just gets rid of the h entirely. So 300 minus r squared divided by 2r is what we had. And so it is now time pretty much to just simplify everything down. So we have an r in the bottom and an r there. They can both be cancelled out with each other. Now we need to multiply everything by pi r. V equals 300 pi r minus pi r cubed all divided by 2. Now what do we want to express it as? We want to just break that up, that's fine. Volume equals 150 pi r minus pi r cubed divided by 2, as required. That really wasn't too difficult. Okay, the volume of the tin, yes, we just worked that out. Using calculus, great. Find the values of r and h for which the volume of the tin is a maximum. Okay, it says using calculus we're going to differentiate. We're differentiating v with respect to r. So, 150 pi times r. Now whenever we differentiate r, it disappears and leaves us with 150 pi. Now we have r cubed over 2. Remember, you're going to multiply it by the power and then take one off the power. So that is 3 pi r squared over 2. Not too bad. Now remember, if this is a maximum, we want this to be equal to 0. 150 pi, because it's just a curve really, minus 3 pi r squared over 2 is equal to 0. So 3 pi r squared over 2 is equal to 150 pi. Let's just bring them over to their own sides. We do have a pi on each side. You can go. If we divide through by 2, or multiply by 2, sorry, I should say, this is going to go to 300. Divide by 3, this is going to go to 100. Which literally leaves us with, if I can get the right pen, r squared is equal to 100, r is equal to plus or minus 10, but remember this is real life, where things cannot be negative, distances or lengths. It is 10. And what is h then? Remember, if we go back to it, h is equal to 300 minus r squared over 2. 300 minus 100 over 2 is equal to, well, wouldn't you know it, 10. Isn't it? Or does I have a mark scheme here because it's always useful to check. And that doesn't look very promising. Oh yeah, that's because I wrote it down wrong. Well, 300 minus r squared over 2r, that's 2 times 10, which is going to be equal to 10. Yeah, well done me for actually writing down the formula correctly and not even showing you. Okay. And now we need to make sure that it is a maximum, because remember, it might be a minimum. So we're going to go d2v by dr squared. We have to go back up to here. This one here. Okay, that's going to go minus r squared, multiply this all by 2, and we get 3 pi r. If we substitute in r as 10, this is going to be greater than 0, that's less than sign, which means well done me again, minus, I was right, it is going to be less than 0, therefore a maximum. Do not be like me and do not forget about the fact that if there's a minus there, there's a minus here. And because it's less than 0, it is a maximum. Clangy noises. Okay. Let's get to the next question. Solve the equation. Okay, now you may see this and go, how? But remember, we are now A level, we can solve this. So, basically we're going to use the factor theorem to find a factor. So f. Now, what you would usually try is you would try 1. And you type that all into your calculator. So 2 minus 8 plus 3 plus 10. Now I know that's not going to be 0. Okay, let's try 2. You'd also try minus 1, but we'll just go to 2. What happens if you put in 2? 2 times 2. That wasn't the cubed sign. There's the cubed sign. You can't even see the calculator. 3 times 2 cubed minus 8 times 2 squared plus 3, 2 plus 10 equals 0. F of 2 is equal to 0. So we know that x minus 2 is a factor. Great, what's next? Algebraic division, I hear you say? Correct. Okay, let's divide. X minus 2, and we are putting that into 2x cubed minus 8x squared. As you can see, I am spacing these out nicely. Let's put the thing over. Okay. There are 2 x's there, and when we put that in, we get 2x squared, multiply through by this, and you get 2x cubed minus 4x squared. Take them away from each other, same sign, subtract, and you get 8 minus 4 minus 4x squared. Bring the next term down, plus 3x. That's minus 4x minus 4x squared. As you can see, I'm speeding up on this. Minus 2 times minus 4 is plus 8x. Taking away, same sign, subtract. You get minus 5x plus 10 minus 5 minus 5x plus 10, 0. And that's also how you know you've done it correctly. So we have our new equation. X minus 2, we worked out as a factor. And then our new equation when we divided, 2x squared minus 4x minus 5. And this is equal to 0. Need to factorize this. Sometimes it's much quicker to do in the calculator because I am lazy. And you have to do this using the quadratic formula anyway. So all I have to do is put in 2 minus 4 minus 5. Nope. 2 minus 4 minus 5. And we get x equals 2. X equals 2 plus root 14 over 2. And 2 minus root 14 over 2. And you know what? You can leave it like that. Those are completely acceptable answers. Okay, we're going to question 8, which I have seen. And I looked at it and thought, great, we love that. Zoom in. Okay, the points A and B have these coordinates. Now these are the questions we have to read everything and draw out everything. So, points A and B have coordinates 2a, a squared, and a plus 1a, respectively, where a is not equal to 0. A straight line perpendicular to AB passing through point A cuts the x-axis at point P. Okay, let's draw this out. We have point A, and we have point B. And the coordinate is 2a, a squared, and the root of this is a plus 1a. Straight line, perpendicular to AB, passing through the point A. So this is perpendicular, so let's join these up. Perpendicular. Say that's probably about perpendicular. It's not, but it's close enough. Cuts the x-axis at point P. So pretend the x-axis is here, and this point here is P. Now we know what's going on. We need to find the coordinates of point P in terms of A. Now, what do we know? Basically, we want to find the equation of this line here whenever A is 0. So let's work out the gradient of this, because that'll give us the gradient of that. So, change in y value divided by change in x value. That's A minus A squared divided by change in x value. A plus 1 minus 2a is our gradient of AB. So I'm going to call this MAB, M for gradient, AB. Now, this is going to be a upon 1 minus a, whenever you factorize that, over a minus 2a. What do you know? We have 1 minus a. That's kind of nice, because that simplifies down to a. Now, because this line is perpendicular, we'll call this AP. M of AP is perpendicular to MAB. Therefore, M of AP is equal to minus 1 over A. Remember, it's something I like to call flip and change the sign. My mum taught me that, thank you mother. That's got me through, not gonna lie. Okay, y equals mx plus c. So, we know that at A, remember we have the coordinates of point A, y is equal to a squared. Our gradient is minus 1 over a. Our x is 2a plus c. So let's work out what our c value is. A squared equals minus 2a over a plus c. The a's will cancel out. A squared minus 2, plus 2, because we're going to bring that over, is equal to c. So our equation is, it's time for y equals minus 1 over a x plus a squared plus 2. How lovely. Now, to get the point where it crosses the x-axis p, we know that y is 0. Let's say that's the y-axis there. Here, y is equal to 0. So, 0 equals minus x over a plus a squared plus 2. This is going well, as you can see. We're actually off the paper because I did print this out small. Okay, x over a equals a squared plus 2. And then we multiply that up. X equals a cubed plus 2a. There's our x coordinate and our y coordinate is 0. So point P, a cubed plus 2a, 0. We have found our point P. Let's turn over, or let's move this up and go to the next question. The midpoint of the line AB has equal x and y ordinates. Find possible values of A in their simplest surd form. Now, if we look back, so I'm going to grab this. Let's zoom out a little bit too so we can see it all clearly. There we go. A, let's just rewrite this. 2a squared, and B is a plus 1, 0. Midpoint AB, so I like to call this mid AB, has the coordinates, so you have to add and divide by 2. 2a plus a plus 1 is 3a plus 1 over 2, and then a squared, sorry, that is not 0, that is a squared plus a over 2. Now, what do we know about the midpoints? Well, they have equal x and y ordinates, so that is equal to that. 3a plus 1, now remember they're both over 2, so we can cancel that out. A squared plus a. Well look, it's a quadratic. A squared, bring that over, we have minus 2a minus 1 is equal to 0. Now, what we have to do, it says in their simplest surd form, so that says to me complete the square. A minus 1 squared minus 1 minus 1 is equal to 0. A minus 1 squared equals 2. A minus 1 equals plus or minus root 2. A equals 1 plus or minus root 2. Always remember to plus or minus whenever you take the square root, and those are our possible values of A. Okay, we are on to the final question, which is usually the most horrific. Okay, let's read carefully and see what we have to do. Hello, motorbike passing. AB is the diameter of the circle. S lies in the circumference. D is on the foot of the perpendicular from B to OS, so yep, D is where they meet, okay. The acute angle BOS is theta. AOA, that's there, equals OB is equal to R. I'm going to write that in. OD is equal to X. Great! This looks amazing. By applying the cosine rule to triangle AOD, okay, that's this one here, show that. Okay, now the cosine rule, let's write what the cosine rule is. Cosine rule says that a squared equals b squared plus c squared minus 2bc cos A. Now remember, these do not have to be ABC, no. They can be really anything. So length AB, that's one length A is the one we don't know. And we're going to call this here AD, because that is literally that line. So, and that's A. So AD squared equals B squared, and we'll call that X, plus C squared, call that R, minus 2BC cos A. Now, that is the angle opposite. We know it's 180 minus theta. Okay, looking quite interesting so far. Now, 180 minus theta, when you take the cosine of that, it actually is the same as, so, why am I writing in red? So, cos of 180 minus theta is equal to minus cos theta. Fun fact, just because of the cast diagram of theta. So we can use this. AD squared equal to x squared plus r squared plus 2xr cos theta. Okay. Now what can we do? It kind of looks like we don't have much to do with this, but if we look at the smaller triangle, this little one here, this is also r, remember? We know what theta is in terms of r and x, because this here is adjacent, this is the hypotenuse. So theta equals cosine to the minus 1 of a over h, which is x over r. So cos theta equals x over r. Isn't that quite useful? We know that x equals r cos theta. So anytime we see an x, let's plug in r cos theta. AD squared equals, oh look, r cos theta, sorry, but we're squaring it, so r squared cos squared theta plus r squared plus 2 r squared cos squared theta, because remember, that's r cos squared theta, that's r cos theta, we have cos theta, there's two of them multiplied together, squaring them, r, 2r, squaring them. AD squared is equal to, let's factorize out, so we have a cos squared theta common, we have an r squared common. Yes we do, so we have r squared upon cos squared theta upon 1 plus 2 plus r squared. So this basically simplifies to 3 r squared cos squared theta plus r squared. This can be simplified even more, or factorized, sorry, r squared upon 1 plus 3 cos squared theta as required. I'll just put AD squared equals the front of that. And that is our as required, and we move on to the last part. We do need this, don't we? Okay. When BD bisects OS, which means that this is also x here, because both sides are the same, find the value of k, where k is a positive integer because AD is equal to r root k over 2. Okay. So, x is equal to r over 2 because that is now radius. That is nice. And we know that OBD, we know what cos theta is. Remember we said that cos theta is equal to x over r. Well, we know that r, or x is r over 2, so cos theta equals r over 2 over r. Cos theta is equal to half. And great, we actually know, we can work out what this is equal to, so cos to the minus 1 of a half is equal to 60. That is very useful. But anytime we see cos theta, we can now write in a half. That's just, in case you wanted to do that. Okay. AD squared equals r squared multiplied by 1 plus 3 cos theta, cos squared theta, so, which is the same as cos theta squared, a half squared. I don't know why it's gone very blue. I'll see if I can fix that. If I can't, sorry. Okay, but we also know what AD is equal to, but let's keep on going. AD squared is equal to r squared upon 1 plus 3 times a half, or squared, which is equal to 7 quarters. AD squared equals 7 quarters r squared. AD, if we square root both sides, AD is equal to root 7 r over 2. And then we know that AD equals r root k over 2. K is equal to 7. If we compare both of those, k is equal to 7. That is the paper done, and that is 100%. Paper complete. That was a good one. It was very difficult, I will say, but congratulations for following along. So, that was a good paper. It was relatively difficult at the end, but I think you've done great. I think you will be able to do it, and if you maybe do it again after a little bit, see, I hope you don't remember the answers, but you remember how to do it, and that's what counts. Hopefully this helped you. Maybe there were some things you were stuck with. Maybe I explained something that you just couldn't quite get the hang of. If so, great. But thank you all for watching, and I will see you all again later. Bye.